Okay, geometry, here we are on page 2 of our notes in chapter 6, section 6.1. Up here at the top it talks about extended ratios. These types of problems are used all the time on SATs, PSATs. Is used to compare 3 or more numbers. The expression A to B to C means the ratio of the first two numbers is A to B, the ratio of the last two numbers is B to C, and the ratio of the first to the last is A to C. For instance, we're of course going to do it with geometry with a triangle, but we could do extended ratios with all kinds of different problems. In a triangle, the ratio of the measures of 3 sides of a triangle are 5 to 12 to 13, and the perimeter is 90. So whenever you have these extended ratios, that just means there's some common factor that's multiplied by all of those numbers to total it up to whatever the perimeter is or whatever the angles would measure to. Here we're talking about the sides. So all you have to do is add in that common factor, which is x. 5 times some number plus 12 times that same number plus 13 times that same number must all equal up to the perimeter of 90. And then we're going to work that out, and of course we'll find our answer. So what do we have here? We got 2530, x is 90, and x is 3. Now 3 is not our answer. That is our common factor. So we now need to find the 3 sides of our triangle. If we have 5 times x and 12 times x and 13 times x, which is 3, of course our sides are 39, 36, and 15. So we're plugging x back in. Very simple. But regardless, and this, like I said, works on all kinds of standardized tests. When you're given those 3 or 4 ratios, stick an x beside them and add them up to whatever they have to equal. Okay, I want you to try these proportions by cross-multiplying and solving. Here we have 1 times 3 are our extremes, and x times 2 plus x are our means. Make sure that when you do x times 2 is 2x, x times x is x squared, a little distributing there. Since we have a quadratic term, a linear term, and a constant term, we need to bring this all to one side and see if we can factor. So I'm going to change it to x squared plus 2x minus 3 equals 0. Make sure you look at that and see how I move the 3 over to the other side. All got it equal to 0 before we factor. Think about how you factor. We need 2 numbers that multiply to be negative 3, add to be 2. So we're going to get x minus 1 times x plus 3 equals 0. We're here going to use the zero product property. When 2 numbers multiply to be 0, one or both of them equals 0. So we get x minus 1 equals 0, which will of course give us x is 1. That's one answer. We get x plus 3 equals 0, which of course gets us x equals negative 3 as our other answer. Woohoo! Often you're going to have 2 answers on these, and that's okay. It's not even a geometry question. Okay, next problem, cross multiply. 5 times 4 is 20. 2x times x plus 3, make sure you distribute, is 2x squared plus 6x. Be sure you know how you got that. I multiplied 2x times x and 2x times the 3. Again, it's quadratic, so we want everything to one side, so I'm going to bring this 20 over, so it equals 0. 2x squared plus 6x minus 20 equals 0. When you are factoring, what's the first thing you always do in factoring? Yes, pull out a GCF. So our GCF is 2, and it's going to be much easier if we pull out that 2 also. Plus 3x minus 10 equals 0. And this 2 here is just going to divide away. If we both divide both sides by 2, 0 over 2 is 0, so we can just let that go away. Our factors here would be x plus 5, x minus 2. We were looking for 2 numbers that multiplied to be negative 10 and added to be 3 equals 0. And our answers would be negative 5 and 2. Woohoo! 2 problems down. Moving on to number 3. If you want to stop the video and see if you can get the answer right, but otherwise I'll keep on going. X times x is x squared, not 2x. Be careful here. We have x minus 3 times x plus 5. You have to FOIL those out. When you have a quantity, a binomial times a binomial, make sure you do your FOILing. FOIL! Okay, so first is x squared. Outer is 5x. Inner is negative 3x. Last is negative 15. So x squared equals x squared plus 2x minus 15. Ah, this is nice. Woo! X squareds are gone. So we get 0 equals 2x minus 15. 2x equals 15, and so x, of course, is going to be 15 over 2, or 7.5. Yay! Moving on. Next problem. Cross multiply. This is an easy one. 10 times x are our means. 10x. Our extremes. Distribute 3 times 5 is 15. 3 times negative x is negative 3x. Okay, solve. Get our x's on the same side. 13x equals 15. And x comes out to be 15 over 13. Awesomeness. Next one. Cross multiply. This one doesn't look hard at all. 4 times 2x minus 1. Be sure you distribute is 8x minus 4 equals 5 times x plus 6 is 5x plus 30. X is on the same side. 3x equals 34. X equals 34 over 3. Oh, horrors. Look at all these fractions. I think I'm going to cry. No, I'm not. I love fractions. Let's keep going. Cross multiply. 4x times x on our extremes. Make sure that is 4x squared. Our means x squared plus 3x times 1 is, of course, x squared plus 3x. All right, so we got a squared term. We've got two squared terms. We've got to get them on the same side. We've got a linear term right here. We have no constant term. But we're still, when we have that x squared term, let's try to get everything to one side and see if we can factor. So I subtract my x squared. I get 3x squared. I'm going to bring my 3x over. Equals 0. Don't panic. This still factors. This has a GCF of 3x. So I have 3x. Pull it out, and I'm left with x minus 1. Those are two factors equal to 0. Zero product property tells us both of them or one of them equals 0. So either 3x equals 0, and that, of course, gives us 0 as the first answer. X minus 1 equals 0, which, of course, gives us x equals 1 as another answer. All right, looking good. Okay, down here at the bottom, make sure you understand how to talk about ratios when it's related to geometry. AD is a median of ABC. You know a median means a line in a triangle that goes from a vertex to the midpoint of the opposite side. What is the ratio of BD to DC? What do you think? Well, if they're equal, if one's 2, the other one's 2. If one's 4, the other one's 4. Two equal things will be the ratio of 1 to 1. What is the ratio of BD to BC? BD is half of BC, so that's the ratio of 1 to 2. BC is twice what BD is. Make sure the order's right. If triangle ABC is isosceles, with A as the vertex angle, what is the ratio of angle B to angle C? Well, we know if this is isosceles, use our laser beams. B and C are equal angles, and equal angles will be a ratio of 1 to 1. Okay, and then the last problem down here at the bottom of page 2, the measure of two consecutive angles of a trapezoid. Haven't talked about trapezoids much, but the thing we know about trapezoids is they have one pair of parallel sides. So the angles consecutive are a ratio of 5 to 7. So again, stick an x beside them. 5x, 7x, they're consecutive interior angles. There's your sacral angles right there. So they add up to 180. You can solve for that. And the other two are 1 to 3. Now don't use an x here. Again, this is a whole different ratio, so we'll use a y. 1y to 3y for the other ones. So we can solve for x by adding those to 180. We can solve for y by adding those to 180. and we can get plug it back in and get all our angles. So give that a try.